As we approach the next two problems, I would say they're pretty important because at the end there's a lot of factoring and canceling. So these are really going to tell you if you know what you're doing or not. That does not factor. That does not factor. This does. Please pause the video and factor this trinomial. Welcome back. Hopefully you took the time to do that. You should have x minus 6 and x plus 1. If you didn't, please fix it, and if you can't figure out why it's wrong, talk to me. Let's bring over the first fraction of x plus, or the first denominator of x plus 1, the second denominator that is different, x minus 6, and neither of these two, we're not going to repeat them because I have both of them already. Go back and see what's missing. This fraction from the bottom is missing the x minus 6. This fraction from the bottom is missing an x plus 1. This fraction from the bottom is missing nothing. Bring over this 1 and that x minus 6 in a quantity. Bring over this plus. Bring over this x and this x plus 1 in a quantity. Bring over this minus, and bring over this 5x minus 2 in a quantity. That is a huge mistake. People will not put a quantity on there. All right, we are now going to distribute here and here, here and here, and here and here. I'm going to write my answer up top. 1x minus 6 plus x squared plus x minus 5x plus 2. Now I will combine my like terms. X squared, let's count, well, we have a lot of x's going on. So we have 1x, this one makes 2x, minus 5 makes minus 3x, and then we have a minus 6 and a plus 2 makes minus 4, over x plus 1 and x minus 6. Again, I want you to pause the video, and I want you to box this problem. Hopefully you've done that. And if you boxed this problem, you got x minus 4 and x plus 1. So this is gone because we boxed it. The reason the box helped is because this plus 1, this x plus 1 and this x plus 1 cancel. So your final answer on this problem is an x minus 4 over an x minus 6. Down here, this does not factor. This does not factor. This does. And it conveniently factors. You should pause the video and do the box. Unless you're just assuming you know more than maybe you do. Please don't assume things. It does conveniently factor through the ones beside it. 9 times out of 10 it will. See, it does because I know I made the problem like that. All right. Bring over the first, bring over the second, and the third one, it doesn't add anything extra, so we're not going to bring anything else over. The first fraction is missing from the bottom. Which one of these two? It's missing the 2x plus 3. This will be a joy to do. This one is missing the x minus 2. And this last one isn't missing anything on the bottom. The bottom matches. Bring over x plus 1. Always bring your binomials over in parentheses, please. And the 2x plus 3 beside it. Bring over this minus sign, this 5, and in parentheses, x minus 2. Please don't try to distribute that in one step because chances are you will do it wrong. And bring over this plus sign and the quantity. Because it's a binomial, notice my use of parentheses, please. 3x minus 13. Now it's time to distribute. This right here is going to be a little bit of a pain. You do 2x squared. You have to like FOIL it or distribute. Plus 3x plus 2x plus 3. Probably missed the days when that's all you were doing, huh? Distribute this. Minus 5x plus 10 plus 3x, and then, because I'm doing this, minus 13. Let's combine all of those like terms. So I see a 2x squared. Okay, 3x and 2x makes 5. Minus 5 means they cancel. Plus another 3 is plus 3x. A 3 and a 10 makes 13. Minus 13 means I actually don't have anything. All over x minus 2 and 2x plus 3. Look at the top. Can you factor the numerator? Absolutely. Pull out a GCF of x. So you end up with an x parenthesis 2x plus 3 all over the x minus 2 and the 2x plus 3. That was very convenient because now the 2x plus 3's cancel and you are left with x over x minus 2. So far, the problems we have been doing have been binomials or trinomials on the bottom. It's time to make sure you know how to do a monomial problem. So when you look at 6, 2, and 8, as long as you pick a number that 6, 2, and 8 go into, you're good. So I pick multiples of 8. So I think, like, can I bring over an 8? No, because 6 doesn't go into it. Can I bring over a 16? No, because 6 doesn't go into it. Can I bring over a 24? There we go. We can bring over a 24 because 6, 2, and 8 all go into 24. Now for the a's. You need to bring over like the biggest one. So I see an a squared, bring that one over. I really hope your volume is on, otherwise you're missing a lot here. Now bring over some b's. How many? Well, which one's the biggest? B squared. Now let's go see what's missing. The 6 needs to be a 24, so it's missing a 4. A squared is good, but I don't have a b squared in that problem. So in order to get 6a squared to this, I need a 4 and a b squared. It's almost like you're dividing. Actually, you are. So for a 2 to be a 24, I knew this one needs a 12. It needs another a and another b, because I need it to be a squared and b squared. This one needs a 3, and it has a b squared, but it needs an a squared. Well, because these are monomials, we can multiply. So these two times each other, just 4b squared. A minus sign. These two times each other, 12ab. And these two times each other, plus, 9a squared. There are no like terms, and since the denominator is a monomial, I don't think there's a GCF either. No, there's no GCF at all, and they're all monomials. That's never going to cancel, so I'm not even going to bother to factor the top, because the top, if it did factor, it wouldn't cancel with the monomial. So we're good. We're all done. All right. As we are stepping it up a level, I'm sure you're enjoying this. Trying to see if there's any others that might be more important to do right now. Yeah, this one's pretty important. The reason is because the denominators aren't going to match very well. So, hopefully you know this is a box problem. I want you to try to box it on your own. Or maybe you've caught up and you've learned my little shortcut to factoring. This is going to be x plus 3 and x minus 2. That's for the first fraction. And the second fraction is going to be x minus 2 and x minus 1. You should be able to box those problems on your own. Now it's time to figure out what the common denominator is. You always bring over these two. So bring over an x plus 3 and an x minus 2. Now, as we approach a second fraction, I already have an x minus 2 over here. You see it? So that means I don't have an x minus 1, so I need to bring it over. So I need to make sure that both of these are over here, which they are, and both of these are over here, which they are. You do not bring another x minus 2 over. Now it's time to see what's missing. The 3 does not have which one of these? It does not have the x minus 1. The 2 does not have which one of these? Or I'm sorry, which one of these? Because it has the x minus 2 and the x plus 1, it does not have an x plus 3. So you bring it over. Now, take your numerators and put them on top. So we have a 3 parenthesis x minus 1. We have a minus sign. We have a 2, and we have parenthesis x plus 3. Now it's time to distribute. This one's easier to distribute, at least. It's not as bad as the last couple have been. So that's going to be 3x minus 3 minus 2x minus 6. Now we combine. When we combine, 3x minus 2x is 1x. Negative 3 and minus 6 is negative 9. And 1, 2, 3, all three things come from the denominator and just plop right down here. This does not factor, so the problem is done. I'd like to get in 2 more problems before we finish the video. So right now, if you could please flip, and we're going to actually do something called a complex fraction. That would be, it might be good for us to do this problem right here, okay? Now the reason it's a complex fraction is because you have a fraction inside of another fraction. So that makes it very complex. What we need to do is get a common denominator in the top and a common denominator on the bottom. So let's move through the top here. We're going to make the top one big fraction. The only denominator I see is an x. So when I ask you, does this thing need anything? Your answer should be, yeah, it was only over 1, so it needs an x. When I ask you, does this need anything? You should say yes. It was only over a 1, so it needs an x. When I ask you if 3 needs anything, you should say no, because it was already over an x. So x times x makes x squared, minus 4 times x makes 4x, plus 3. The bottom, we're going to do the exact same thing on the bottom. So an equal sign and a fraction bar. The only denominator I see is an x. This x was over 1, as was the 3. Because of that, they both need the x. So this becomes x squared plus 3x, and the minus 4 already had it, so we just bring over the minus 4. Now we finally have a problem like we did yesterday. It's a division problem. So we rewrite the top We rewrite the numerator, x squared minus 4x plus 3 over x, and we multiply by the reciprocal of the bottom. Conveniently, the monomial of x's cancel, and we need to box this and box this. So in a box, you should be able to do this. Again, I encourage you to pause the video. You should get x minus 1 and x minus 3. When you box this, you should get x plus 4 and x minus 1. From 8-4, you learn anything at all on the top, so anything above this line can cancel with anything exactly the same below the line. That means x minus 1 and x minus 1 cancel, and you are left with x minus 3 and x minus 4. The last problem I think that we should do kind of for the good of everybody is this top one up here. Unless I can get it done within a minute or two, I think this is going to be the last one. I need you to box this stuff right here. You should pause the video, and after you push play again, you should have x plus 5 and x plus 6. If you cannot factor these, it is essential that you stay after and make sure you get help. You're going to factor this one. Again, you should pause the video and try the box or your grouping or however, guess and check you factor. And you should get a plus 4 and x plus 5. Let's find our common denominator together. It's always whatever the first fraction is. I sincerely hope you are listening, because if you are not wearing headphones, it's really going to hurt you. So we have an x plus 5 and an x plus 6. What's different on this one that I need to plop over? Is x plus 4 over here? No. Is x plus 5? Yes. So that means you need to accommodate for the x plus 4. You need to bring him over. You don't need the x plus 5 again because you already have it. We need to go backwards and see what's missing. So I have 2 things. The thing that's missing is an x plus 4. It's like, which one of these doesn't belong? Which one's missing? The x plus 4 and the x plus 5 are great, but it's missing the x plus 6. Please bring over the top. Do not assume you know how to distribute, because that's where kids start making really silly mistakes. So I'm bringing over my x and in parentheses x plus 4. I'm bringing over my minus sign, my 5, and my x plus 6. A lot of students, again, they distribute right away. They totally miss that negative sign, and it makes a huge difference. Distribute now. X squared plus 4x. Distribute now. Minus 5x minus 30. Now we can combine our like terms. So we get x squared, a minus x, and a minus 30. All over 1, 2, 3 things.
Please excuse the interruption. At this time, middle school math PSA testing is complete for the day. At this time, middle school students, please move back to your regularly scheduled events, and all the teachers.
This top up here, it does factor, and it factors into a box problem or a grouping problem, however you want to see it. And that is going to become, again, I'm suggesting that you pause the video and try it yourself. I certainly am not going to factor for you on your test or your quiz or your homework. It should factor to x minus 6 and x plus 5. And you get x plus 5, x plus 6, x plus 4 on the bottom. And do not think that the x plus and the x minus 6 cancel. They're totally different. The x plus 5s cancel, and you're left with, on the top, an x minus 6 only. You can put it in parentheses, but you don't have to. And on the bottom, an x plus 6 and an x plus 4. There you go. That's the end of that problem. Now, I think when you come back tomorrow and we're back together, we should probably do, where did it go? There's one with a whole bunch of U's and V's in it. This one right here. But let's do a quick thing. Why don't all of you decide, does this factor, or does this factor? Well, there's no squareds or GCFs. No squares or GCFs. This one is going to factor. Why don't we see if any of you can factor that one by yourselves? And then this would be a good one for us to do tomorrow together.